Hello, welcome to Introduction to Calculus. In this very first video, we're going to look at tangent lines. In particular, we're going to look at a parabola, the basic graph y equals x squared, and we're going to draw some tangent lines and calculate the slopes and see how this all works out. Now remember, a tangent line is a line that just glances off the graph. So if I was going to be looking at, let's say, this point right here, a tangent line would look roughly like this. It would just glance off or just be tangent or just touch the graph at only one point. This would not be a tangent line if I drew something like this, because although it touches the graph, it doesn't look well tangent. It's not just glancing off the graph. And so we need to make sure our tangent lines, of course, are drawn properly. And we can also do that with a ruler. In this video, I'm going to use a line tool to make sure that these tangent lines look pristine. So here we have the tangent line when x is equal to 0. It's going to be a nice flat horizontal line. And hopefully you remember the slope of a horizontal line is simply 0. Now let's go ahead and do a more interesting point. Let's look at 0.25. So that's halfway between 0.2 and 0.3. So the point we're looking at is right here on the graph. Now we need to draw a nice tangent line, so let's go ahead and do that. So there we go, we have a nice looking tangent line. But now we need to calculate the slope of this line, and it's a little tricky because this line, well, it's not horizontal. And if you remember from grade 10 math, we know that slope is going to equal to rise over run. So we need to figure out how much this line rise is and how much it runs. Another way to do it, if you don't want to think about rise over run, is it's y2 minus y1 over x2 minus x1. So what we could do is pick 2 points and compare the y values and the x values in this formula. So we already actually have a point. We have this point right here. We have 0.25, and we could use that point right on the graph, or we could go ahead and pick another point. It's really up to you. Any 2 points will work. I'm going to go ahead and pick the point that looks right here on the x-axis, right about there. And then where it ends actually looks like a pretty good point too. I'm looking anywhere it looks approximately on a grid marker, where the grid we can actually read off the values. So over at this point here, it's 0.5. And then over here, well, it's going to be an extra grid tick. So this is 0.1, this is 0.2. Each of these is going to be, well, there's 4 of them, so it's going to be a quarter. And the decimals are a little tricky here. This is going to be 0.1, this is going to be 0.1 and then 25, 0.15, 0.175, and then 0.2. So let's go ahead and grab this first point here, which is 0.5, and then 0.175. This other point over here is going to be, again, it's going to be 0.125 because it's on the x-axis, and then 0 for the y value. So we'll get 0.125, comma 0. So let's take both of those and plug them into our formula. So we'll get y2, which is going to be, let's say that second point, 0.175, minus y1 of 0, x2, 0.5 minus x1 of 0.125. So go ahead and grab a calculator and we'll figure out what we get here. So working this out gives 0.467. So it's approximately 0.4647. That's going to be our first slope. I'm going to put it just to 2 decimal places, 0.47. Alright, so I encourage you to pause the video here and go ahead and try the other points. Try 0.5, 0.75, and 1. Draw tangent lines for each one of those and see what you get for the slopes of those tangent lines. Alright, so assuming you give it a try, I'm going to go ahead and draw them on the graph to make sure we have roughly the same slopes and tangent lines. For 0.5, that's going to be over here. And the tangent line will look like this. So if we go ahead and find some points there, we could probably grab this point over here, and maybe this point over here. You can choose the endpoints of the line segment. You can choose any point on there that looks easy to calculate. So over here, it looks like 0.65 and 0.4. Over here, we're going to have 0.325 and 0.075. So let's go ahead and figure out what that will give us. So we have the y value of 0.4 minus the y value of 0.075 over 0.65 minus 0.325. And that will give us, well, this one actually works out pretty nicely. We get a nice even value of 1. So the slope for this tangent line is going to be 1. Now if you go ahead and do the other ones, you should get approximately 1.5 for this one and approximately 2 for this one. Now again, your numbers might be a bit different. You might get 1.4, 1.6. Over here you might get 1.8 or maybe even 2.2, but these should be your approximate values. So let's go ahead and take our values that we got for the slope of the tangent. Let's do something interesting with them. Let's take these slopes and plot them on a graph. So we have our values here. Let's say this was your table. You've got x, and then here we've got our slopes. So 0, 0.25, 0.5, 0.75, and 1. And let's plot those slopes. Well, 0, this one was about, I'm going to round it maybe just to 1 decimal, 0.5, 1, 1.5, and 2. So let's plot those here. We'll have 0, 0, 0.25 and 0.5, 0.5 and 1, 0.75 and 1.5, and 1 and 2. Now looking at this, it should feel almost automatic. You see these dots on the graph, and what do you want to do? Hopefully your intuition is the same as mine. Hopefully you want to connect those dots. And if you look, well, those dots look like they connect really nicely. If you have your ruler handy, it should go through, again, not exactly because your points here might be a little bit different, but almost perfectly it should go through there and you get this nice looking line. Now, I'm going to ask us a question here. This line right here, what's the equation? What is the equation of this line? Does it have an equation? Well, hopefully you remember the equation of a line is y equals mx plus b. Now b in this case, because we have an intercept here of 0, b is going to be 0. So that's just 0. And m, the slope, it looks like this line, if we were to do slope again, it goes over 1 and it goes up 2. So rise of 2, run of 1. So y equals 2x. We started with the equation y equals x squared. Now we have the equation y equals 2x. We did a lot of work as we were going from this equation to this equation. We had to draw some careful lines, we had to find the slopes of these lines, and then we had to plot these slopes on another graph. It took a lot of work. This was definitely cumbersome, maybe very delicate. You didn't want to miss any of the points. You had to be careful with all of your decimal work. And in the end, you got this new equation, y equals 2x. The question would be, if I was to go from here to here, would there be a shortcut? Would there be some way of doing this process faster? Would there be some kind of rule or method that tells you, hey, if you start with a parabola y equals x squared, you know that after this whole process of slopes of tangent lines and plotting slopes, you'll just get 2x. Maybe you think to yourself, well, yeah, this 2, and then there's a 2 here. Maybe there's some connection, some kind of pattern there. But you're not quite sure. You're not quite ready to say what the pattern would be. And certainly if I put up an equation like y equals x cubed, and you were to try to use a shortcut to get to the answer really quick and not have to do all this graphing and rulers and plotting, you might be not so sure on what the shortcut would be. And so the goal in calculus is we're going to try to find this shortcut. We're going to see, is this shortcut possible? Is there such a thing as a way to go from here to here in one step? And if so, what's the shortcut? What's the rule? What's the way of doing it? And so keep this in the back of your mind as we begin to look at this course, as we begin to study some of our concepts. We're going to be looking for this shortcut to see if there is a way of doing this faster. There might be. I'm not sure yet. We'll have to stay tuned. And as always, thanks for watching.